And with 4.3, we're still doing systems, but this time it's going to ask you to solve by elimination. Okay, now here's the key thing with elimination. What you really want with elimination to make this thing work out to be the easiest thing you can do is you want the same value, or the same coefficient, on the same variable. So we've got this system where we've got the two equations. So you want the same coefficient on the same variable where one is positive and one is negative. Okay, so that's the whole thing you're trying to get with elimination, is that whatever equation they give to you, you want it so that everything is going to be the same. Either both of the x's have the same value or both of the y's have the same value, the same coefficient with those. And once you've got them so they've got the same number where one's a positive and one's a negative, then you just add the equations together. Why do they keep doing that? And once you've added the equations together, that if one's positive and one's negative, they're going to knock each other out. That variable is gone, which that's the elimination part. And once you've got one variable eliminated, you just solve for the remaining variable. So then we'll use that value to plug into any original. To find the other variable. Okay, and just like in the elimination, or sorry, in the substitution part, you're still looking for x value, you're still looking for a y value. This one, the other one, the easy work was in the back end of the problem. This one, the easy work is probably more in the front end of the problem when you go through these. And we'll start you off with one that's relatively simple, and then we'll add a couple of steps to it so it gets a little bit more difficult with each one that we go through. Okay. And this one will tell you to solve with addition. Now, it's still elimination, but they're going to tell you for this part of it, even though it's elimination, we're still going to just use addition to kind of get us through this problem. Okay, so very first thing is, if you notice with this one, you've already got 2x and 2x. So you got a positive 2x, you've got a negative 2x, so for that one, just add it. And now, when you add and subtract these, just add it, stack them up one piece at a time. Do 2 minus 2 to make that 0x. You've got negative 3 plus 6, that would be a plus 3y. And then 4 minus 10 would be negative 6. And the whole point of that one is that once you get 0x, you don't need it, it's gone. So now you've just got 3y equals negative 6. Divide those two, and you've got y equals negative 2. And that's why most people like this one better, because you get one answer right off the bat in just a few seconds. Where in the other one, you've got to rewrite it, plug it back in, do some distributor property, solve the equation, go through that one. This one, most of the time, it's just, boom, there's the answer. It comes to you that quick. Now, the longer part on this one is plugging the numbers back in to get the second answer. It takes a little bit longer, where in the other one, all the work, the harder work was in the first answer, first variable. You got a pretty quick answer on the second one. This one's kind of reversed. You get a very first easy answer. The second one takes a little bit more work. Okay, so now we're going to plug this into any original. Find x. And it does, and this is one of those cases where it really doesn't matter. It's just whichever one you think is the easiest, because with most of the original problems here, it's about the same either way. Occasionally there's one that might be really easy, but most of the time there's really not a difference on these. Just pick one here. We're doing equation 1 and equation 2. Let's just pick equation 1. Again, it doesn't matter if you pick 1 or 2. I'm just going to go with 1. So we've got 2x minus 3y equals 4. Okay, and for the y, we're going to use negative 2. Okay, so this one. The good thing about this one is you don't have to do distributive property. It's just one multiplication. So you've got negative 3 times negative 2. That's positive 6. Subtract the 6 from both sides. And then when you divide by 2, you get x would equal negative 1. And there's the two answers you're looking for. Okay, so it works out great if the first numbers are perfectly matched up, where you've got a positive 2 and a negative 2, or a positive 3 and negative 3, and everything's great and it all works out well. Let's show you one of these where that you get the beginning, it's almost where you want it to be in the beginning. Sure. Give you one where it almost is perfect in the beginning, but got to do one little thing to it. Okay. Because usually we always show you the one at the first where everything's perfect, where you got a positive, positive 2, negative 2. This one we're going to change it where in this case you've got both of them are 4x's. So we've got the right numbers, but the signs are not what we want them to be. Now, some people will just say, oh, we'll just subtract them and it'll be okay. And you can do that, and it's absolutely fine. But having taught this one, here's the best thing to do. That before you start subtracting these, because most time people will subtract this and they'll remember to subtract this one, but one of them they'll usually forget. If you've got the same number, but one of the signs is, both of the signs are positive, or both of the signs are negative, what you want to do is multiply one of the equations by negative 1. And it doesn't matter whether you do that with the top equation or the bottom equation. Just pick one of the equations that you have and multiply it by negative 1. And I kind of like, to me, if I have to pick, usually I pick the bottom one. So let's take this bottom equation we've got here and multiply it by negative 1. So that's just going to change it to negative 4x minus 3y and negative 12. If you don't, again, if you do subtraction, that's fine. But I've found that when you do that, sometimes people forget to subtract one of the numbers. So just so that you don't do that, I would say just multiply the thing out by negative 1. because we're going to take equation 2, just multiply it by -1 to get it here. So now we've still got equation 1, and all we've done is we've taken equation 2 and just multiplied by -1. Okay, now you've got the same numbers with the different signs. Now you can just start putting it together. 4 minus 4 is 0, x. And again, if it's 0x, it's 0, so it's gone. 5 minus 3 is 2y. And then -4 minus 12 is a -16. Okay, and again, once you've canceled this part out, the work from here, once you solve it, is really pretty easy. Just take -16 divided by 2. So y is -8. Okay, and again, once you've got the y equals -8, plug that back into any of the originals. Last time we picked equation 1. This time let's just go with equation 2. So we'll go 4x plus 3y equals 12. Again, doesn't matter. Just pick one and go with it. Okay, so taking out the y, replace it with -8. We've got 4x plus 3 times -8 equals 12. And again, instead of doing distributive property, just going to multiply these two together and make it a -24. Add 24. And then divide by 4, and you get the x equals 9. Okay, so if they ask you to do addition, that's pretty much your two choices. Either you've got the right numbers with the different signs, or you've got the same signs with the same numbers, and you just need to go back and multiply one of the two equations by -1. Okay, and then the next thing they'll throw at you, still doing elimination on these. Is they're going to ask you to solve the system. Again, these are all still elimination with multiplication and addition. All right, let's go with 2x minus 3y equals 4. All right, so for this one, let's go with x plus 5y equals 15. Okay, now here's where the multiplication comes in. Is that when you look at this one, you don't have the same number on x, you don't have the same number on y. So if you don't have the same number, So when you don't have the same coefficient. On the same variable. You can multiply either or both equations by any, pretty much any number you want to. Now we're going to say not zero, because if you multiply by zero, that doesn't do anything because it wipes out the whole equation. But you can multiply by any non-zero number. And it could be that you only have to do one equation. Sometimes we'll do some where you have to do two equations. But you can pick any equation, multiply by any non-zero number that you want to. And this is one where it's in between, where you really only have to multiply it by one equation. That for this one. You've got 2x and basically you've got 1x, right? This one you've got 3 and 5. Well, you have to find the first number they have in common multiple-wise. So if you started counting by 3s and 5s, the first number would be 15, which means you'd have to multiply this equation by 3, this one by 5. But if you've got 1 and 2, first number they have in common is 2, right? So all we really need to do for this equation is we're just going to multiply this equation by 2. And there goes my next point. You actually want to make it a negative because this one's already positive, correct? So you want this one to be negative, so let's just multiply it by negative 2. That way you can make a positive 2x, then you've got a negative 2x, and then we're good to go. So for this one, multiply everything by negative 2. So that's a negative 2x. It's a minus 10y and a negative 30. And for the top equation, we didn't have to do anything with it because it was already a positive 2x. And now that you've got the positive 2x and the negative 2x, they'll cancel each other out. And then we can just go ahead and start adding this thing together. Okay, so if we do that, we've got 2x minus 2x, that's 0x, that's gone, that's what we want. Negative 3 minus 10, that's a negative 13y. And 4 minus 30 is negative 26. Alright, divide those two. Get you y equals 2. Okay, and I'm right up against the page on this one, so when we plug it back in, we'll just see if we can, well, we'll go to the next page. But we'll kind of pause right there and let everybody get caught up. Okay, so we've got y equals 2. And again, we can just pick, doesn't matter which equation you pick. To me, it looks like the equation 2 back up in the beginning might be the easier one, so we're going to plug that back into x plus 5y equals 15. We're going to do that on the next page because I'm out of room. So x plus 5y equals 15. And we had x, y was 2. Is that what we have? Is it y equals 2? Okay, so we're going to plug in y equals 2. So we're going to take out the y, plug in the 2. We've got x plus 5 times 2 equals 15. And we get x equals 5. Okay, so there's one where you've got one equation that's, you can look at it and go, okay, well, the numbers aren't the same, but I've got 1 and I've got 2, so it's really easy just to take one equation and multiply it out. And usually that's kind of the middle step where that if you look at the numbers, one of the numbers on the variables is a multiple of the other one, and all you got to do is just multiply one equation. Where they make it a little bit tougher, and this is about as tough as it gets, is where you have an equation, or both of the equations, and neither one of the variables really matches up with the other one. number 3? 4? Okay. So negative 2x plus 3y equals 11. And then we'll go with 5x minus 4y equals negative 10. It is. There you go. Move the pen. Okay, now, and again, here's what you're looking for. 3 and 4s, they're not multiples of each other. 2 and 5, they're not multiples of each other. So if there's nothing you can do to multiply it now, somebody can say, what about use a decimal? That's great, but if you want decimals all over the place, then yeah, you can use decimals. But, you know, if you look at 2 and 5 and 3 and 4, they're not multiples of each other. So the only option you have then is pretty much just to tell me, all right, if it's 3 and 4, what's the first number they'd have in common if you start counting by 3s and 4s? Both be 12, right? Now, and you can pick, either do it with the y's or you can do it with the x's. If it was 2 and 5, first number they have in common would be 10. So you can either write both of these so you have 10x and 10x, or you can rewrite both of these so you have 12y and 12y. And that's really your choice of which one you want to do. To me, just for this one, just the look of it, I'm going to go with the 2's and 5's. I'm going to make this thing out to be 10. So to get from this equation to here, so that they're both 10x, I'm going to multiply this equation by 5. So that's negative 10x plus 15y equals 55. And this is one of those times where you don't get in a hurry, because sometimes you get in too big a hurry, you can leave one little number off and it throws the whole thing for a loop. Okay, for the second equation, got to multiply by 2. So 5 times 2 is 10. And now again, we don't have to worry about changing the sign because this one was negative and that was positive to start off with, so we didn't have to change any signs, so that was good. Negative 4 times 2 is negative 8. And then negative 10 times 2, that's a negative 20. And there's the new equation that we're looking at solving now. Okay, so now you've got negative 10, positive 10. That goes to 0x. That's what we want. That one's gone. 15 minus 8 is 7y. 55 minus 20 is 35. Divide those two. You get y equals 5. Yeah, and really, here's the key thing you're going to do. Whatever the two numbers are, the easy way to think about it is just flip-flop those two numbers. Put the 5 up here and put the 2 down here. And you can multiply it out and go from there. So you're just going to reverse the order. Basically, you need to multiply the second equation by 2 and the first equation by 5. Same thing here. We could have taken the 4 up here and the 3 down here and had 12 and 12 to kind of get those numbers. But that's kind of the way you want to think about it, is just think about your multiples of where you want to get to. So 3 and 4, they both have to be 12. If we're going to do that one, 2 and 5, we can get 10. The only difference is if you pick x versus y, then one time you're going to get y first, the other probably you get x first. But you should still get the same answer no matter what you do. From here, still got to go ahead and find out the x. So we're going to plug it back in to find x. And I would go with the originals because they're going to be smaller numbers. They should be easier to solve because the numbers are smaller. Does it really matter which one's which? No, not really. I got one you want to pick? 1 or 2? Do the 2x plus 3. Okay, so let's go negative 2x plus 3y equals 11. I'll plug in the 5 for y. Negative 2x plus 3 times 5 equals 11. 3 times 5 is 15. Subtract the 15. Negative 2x equals negative 4, so x would equal 2. Okay, let's do another one just to make sure it's, seems like it's that easy. Okay, let's go with 7x minus 4y equals negative 13. And then we'll do 8x minus 5y equals negative 11. Okay, and again, you're just looking at the numbers. With the x's, you've got 7 and 8. Well, they're obviously not multiples of each other. 4 and 5, obviously not multiples of each other. So then you just got to figure out, okay, I've got 7 and 8. The first number they have in common is 56. 4 and 5, the first number they have in common is 20. Do you want to use 20 or do you want to use 56? I'm thinking 20, right? 20 is smaller, so let's go with the smaller number when we're going through these. So we've got the negative 4 and the negative 5. We can make those out to be 20, so let's rewrite them both so they're 20. So to get from here to here, for that to be 20, got to multiply by 5. So we got 5 times x, that's going to be 35x minus 20y equals negative 65. Okay, on the second one. Now, we want this one to be positive 20, right? Because we know it's going to be 20, but if this one's negative, this one's got to be positive. So to get from negative 5 to positive 20, I need to multiply by negative 4. So negative 4 times 8 is a negative 32. Negative 5 times negative 4 is a positive 20. And a negative 11 times negative 4, that's a negative 44. Now, and if you happen to go through this one and you get to the end and you're like, oh, they're both negatives, then just take the equations, one of the two, and just go back and multiply it by 3 by negative 1. So if you forget to change the signs, it's not a big deal. Just go back and multiply one of the equations there. But it would be, yeah. Thank you. Ah, see, y'all are paying attention. There we go, yeah. Okay, so now we got the signs correct. All right, so now put them together. So this one's not too bad. 35 minus 32, that's 3x. Not too bad at all. You've got the negative 20, positive 20, that's a 0y. So again, that's gone. Negative 65 and a positive 44, that's going to be a negative 21. And we divide those two, you get a negative 7. Okay, and same thing as before. Now that you've got the x, you've got to plug it back into any ones that you want to get y. Again, I'd go back up here because the numbers are smaller. We picked equation 1 last time. Let's just go with equation 2. Okay, so we're going to take out x and put in negative 7. Got 8 times negative 7 minus 5y equals negative 11. 8 times negative 7 is a negative 56. To get rid of the negative 56, we want to add 56. Again, a little bit bigger numbers, but it'll work its way out. So negative 5y equals 45. Divide those two, you get y equals negative 9. There we go. Okay. So, and again, that's a worst case scenario where the numbers aren't multiples of each other. If that's the case, you pretty much can just multiply the two numbers together to get what you need. And then the last thing they're going to do, still going to have you go through and solve these, but they kind of give you a heads up and tell you that these problems could be inconsistent or consistent dependent. And we'll show you what those two things mean here. Okay, so here's the two things you got to know. When it talks about if it's inconsistent or if it's consistent dependent. Those are just a fancier way of saying that if it's inconsistent, that one means it's no solution. Yep. If it's consistent dependent, that just means that's fancy for infinitely many solutions. Now, if we tie that back in with what we were doing in 4.1, that if it's no solution, this means that you have parallel lines. If it's infinitely many solutions, that means it's the same line, just rewritten two different ways. So that's where they're going to tie this back into what we were doing back in 4.1 when we were actually graphing the lines. So if it's inconsistent, that means it's no solution, which means it was two parallel lines. And infinitely many means it's just the same line on top of itself. So it's the same equation, they've just written it two different ways. Can I go through these? Now, when they do these, the problem itself is going to look a little bit different when they set this problem up, because they're not going to just give you one equation or one system. They're going to give you two or three systems. I think so far it looks like they're all two different systems here. So we'll kind of show you that one now. This is at the bottom of the page, so I'll start back on a fresh page here. So they actually start by just giving you a big giant box with 4 different parts here. Slide this one down just a little bit. Okay, and let me do one this way, and then we'll come back and do another one. Blow that here in a second. But they'll give it to you in a setup where you've got two different problems, and you've got the same thing here, so we'll just put the second one right here. Let me do that. So the second problem, let's do it like this. We'll do 4x minus y equals 8, and negative 4x plus y plus 8 equals 0. And you'd have the same 3 dots over here. You've got the no solution, you've got the unique solution, and you've got the infinitely many. Now, here's the catch on the infinitely many with this one. And I think, if I remember back in 4.1, you may have had to do the same thing. If you do get the infinitely many solutions, they want you to write that answer in y equals mx plus b form. So they've already given you the y equals. You just got to go back and put the mx plus b back here for this part of the answer. And I think you had to do that, if I'm remembering correct, in the 4.1 homework. If you had the 2 lines on top of itself, I think you had to do the same thing. I think so. Okay. So it's basically just going back and doing a repeat of what we did back in 4.1. Okay, but let's take this first part that we've got here, and we're going to solve this thing. And we're just going to do the work down here at the bottom, and we'll come back and work it out. So we've got 4x minus y equals 4. We've got negative 4x plus y equals negative 4. Okay, the good news with this one is you don't have to multiply, you don't have to rearrange anything, everything's lined up. You've got 4 minus 4, which is 0. 0x, so that one's gone. But at the same time, you've also got a negative y plus y, which is also a 0y. So basically, you've got 0 plus 0, which is 0. And then 4 minus 4 is 0. So does 0 always equal 0? All the time, right? So if that's always true, then that means that's the infinitely many solutions. Yep. Because you're back to that key thing of you want the first 2 terms to be the same number, but different by the plus or minus sign. So then you can just add them together. Okay. Okay, now here's the extra part. If it's infinitely many solutions, they want you to take, and it doesn't matter which one you pick, you've got to rewrite one of these in y equals mx plus b form. Hope everything's okay. Yeah. Okay, so I would say if you're going to rewrite one of these, this one's already got a positive y. Let's work with that one. So let's take the negative 4x plus y and rewrite that one. So from here, let's just add the 4x to both sides. So y would equal 4x minus 4. And that would be the part they would want you to go back and put in the box on the answer once you've clicked on the always true part of it that's there. Part 2, we're going to go with this equation. We're going to go 4x minus y equals 8. So that was part 1 up here, then we'll go part 2 right here. It was 4x minus y equals 8. And negative 4x plus y. Plus 8 equals 0. Okay, first thing is when you have this one, everything's not lined up. So you've got to rewrite this equation so that it lines up. with the top equation, which was what we're calling the E1 here. So for this one, the x's are good, the y's are good. We just need to take this 8 and move it over to the right-hand side. So for this one, all we got to do is just subtract this 8 and move it over to the right-hand side. So we've got 4x minus y is equal to 8. This one we've got a negative 4x plus y. When you move this over, now it's a negative 8. Okay, and usually it just takes one term. There may be sometimes you might have to switch two terms. Maybe the x's and y's are all out of order. But usually it's just a matter of just moving one term. Maybe sometimes you might have to use two terms to move them around. And then once you've done that, you've got a positive 4 or negative 4, so we're good to go. 4 minus 4 is 0. Negative y plus y, also 0. 8 minus 8 is also 0. Back to 0 equals 0, so that's always true. So that means that would be infinitely many solutions. So again, what we've got to do is we've got to take one of these two equations and rewrite it in y equals mx plus b form. The easiest one to use is going to be the one that's got the positive y, so let's use the one that's got the positive y. Because all you then have to do is just get rid of this x. So just add 4x to both sides. Okay, now, the one thing we didn't do, I thought that was going to work out to where it was no solution. Let's give you one where we've got a no solution answer, just so you can see what it looks like, for sure. That one was the second problem. Yes, I plugged it into this second equation right there. Now you should get the same answer no matter what you do. Because this one, because it's a negative y, once you subtract the 4, if you picked equation 1, yeah, because you would have had, if you moved this over, you'd have had a negative y equals a negative 4x plus 8. And then you'd have to change that sign to make it positive y. If you change one sign, you got to change all the signs. Okay. And when you're going through these, just because you get one problem that's got, if the first answer is infinitely many solutions, don't just automatically assume that the answer's out. Sometimes you get some repeat answers. And some of these problems you'll get, one of them will be no solution. The next one might be that x equals 2 and y equals 3. So they'll kind of mix these up when you're going through the problems here. So there's, all kinds of different answers you possibly could get off this one. All right, here we go. Let's just do this one. This will be pretty quick. Make this one short and simple, because once we take a look at it, you can see how it works out. So let's go x minus 3y equals 6, and then negative x plus 3y equals 6. Okay, so we're good here because you got positive 3, negative 3. So when you add or subtract these, you've got 1 minus 1, that's 0. Negative 3 plus 3, also 0. 6 plus 6 is 12. Can 0 equal 12? Nope. There you go. No solution. Okay. So the no solution should be that easy that when you add or subtract the numbers based on what they are, you get a 0 on one side and you get something other than 0 on the other side, and that's as far as you have to go. Okay, and there's one more problem that you have to do. There's only one objective with this one. It's in section 4. We're going to go ahead and put it in section 3 because it's pretty much the same type of problem, but it's everybody's favorite kind of problem. Yeah. And we'll just simply title it, it's a word problem. Oh, yes. Oh, actually, let's go ahead and put this on a separate page because it's right at the bottom of the page here. So. Okay, so I'll try to cut out as much of the fluff and stuff as I can here. A store sold 222 books. Let's say they sold 74 more algebra books than geometry books. Now, this is a very weird bookstore because that's the only 2 books they sell. They don't sell anything else. They just sell algebra books and geometry books. That's it. If you want, chemistry or biology, you got to go to a different bookstore. This is a math-only bookstore, and they only carry algebra and geometry. Okay, now, for the word problems on this one, they're not going to be really overly complicated word problems because the very first line basically gives you the first equation. If they have 2 different types of books and they sold those 2 different books, well, that's x plus y equals 222. Had 2 different types of books. They totaled 222, so just do one of them as x, one of them as y. Now, here's the thing on this part. It doesn't matter which one's x and matter which one's y. In the problem that you do when you put the answers in, they should give you a blank for algebra and geometry. You just put in the 2 numbers and you're good to go. Or if it's chemistry and biology, or if it's French and Spanish, or whatever it's going to be. The other part of it says they sold 74 more. Here's the key thing. If it's 74 more, right? That means it's something plus 74. And it doesn't matter which variable you let it do which one it is. If you want to say that y is x plus 74, you're good to go. Or you can say x is y plus 74. It doesn't matter because one of them is 74 more than the other one. There you go. There's your system. Okay, now, and the way they've got this one set up is they've got it set up, probably the easiest way that you want to do it is to do substitution. But you could also do elimination if you want to. Because if you want to do substitution, you just take out this y. So you've got y equals x plus 74, so replace the y with x plus 74, and we're going to do that in equation 1. Okay, so we're replacing y with x plus 74. So we've got x plus, take out the y, replace it with x plus 74. All right, now the good news with these type of word problems is you don't have to worry about doing distributor property because there's just 2 books. We're not multiplying and doubling products or tripling or anything. It's just the 2 books together. So now you've got x plus x. That'll make that 2x plus 74 equals 222. subtract the 74. Don't know why it keeps doing that. Let's see if we can take that out. Hey, there it goes. We've got 2x would equal, that's an 8, that's 11, that's 148. And then divide by 2. Okay, so there's one of your answers. Now, right now we don't know which book it is because we've just got 74. To get the other number, if you know that the total is 222, take away this book, this amount you have. Well, that was right here, right? We did that same thing. This one kind of worked out kind of odd because it's the same number twice. So if one of the numbers was 74, the other one was 148. Normally it doesn't turn out that you kind of get that part of it here. So if that's x equals, then this would have to be the y equals. Now you just go back and look at it and figure out which one had the most books. We had 74 more algebra books than geometry books. So the bigger number has to be algebra. And the smaller one would have to be geometry. Okay, now, you want to know the shortcut to do this one without having to go through and set up the systems? Okay. As long as we're doing that with the problems where we're not having to double anything or triple anything, or, you know, if they said that there was twice as many minus 5, all bets are off. But if it's just something simple where you've got two sets of things, and one time they add up to a total and it says this one has 15 more or 75 more or whatever, all you have to do is when they give you the total, subtract these two numbers and then divide by 2. That's it. That's all you have to do. So let me just give you another word problem real quick that we can give you, because that one was kind of a... we'll just say that, and we'll keep this as short as we can. The total sold was 315. We sold 57 more burgers than chicken. How many of each did you sell? Okay, now, and again, they don't ask you to set up the equation on it, so as long as it's just, here's a total, and we didn't do any doubling or tripling or anything, we didn't have this 2-for-1 deal or anything, just take whatever the number is that's your total, why does it keep doing that? Somebody had 57 more than the other one, right? So it's like somebody had 57 extra. So subtract out the extra. So take out the 57. Because if you take out the extra ones that they sold the same amount, correct? So just do 315 minus 57. That's going to be an 8. That's a 5. 258. So that equally together, they sold 258. Take that number and then just divide it by 2. That's 129. So as long as they're equally shared, and again, we didn't have a 2-for-1 deal and we didn't double anything or triple anything, they give you a total. They told you this one had 57 more than the other one. Take out the extra one that the other one sold. Now they've got an equal amount, and just divide that amount in half. You've got the smaller amount. So to get the other amount, just add the 57 back to it. Or again, you could just take the total of 315, take out the 129, and you've got the other amount you have here. So that might be the easier thing to do. So here's one amount. We don't know yet which one it is, whether that's the chicken or the burgers. But if we know there was 315 total, take out this one amount. There you go. You got 186. So here's the other amount. And since there was 57 more burgers, that's your burgers and that's your chicken. So that's kind of the short way. They give you a total. They're going to tell you this one had 57 X. There's something that's going to have 57 more, or even had 57 less. It still doesn't matter, because if whether one's got less or more, somebody sold more than the other one. Take out the difference that's there. Just subtract those two numbers. Now they share an equal amount. Divide that amount by 2. And then you know what one of the amounts is going to be. And then just add or subtract that from the total. You've got the other amount that's here. Now here's another word problem you can get that doesn't talk about burgers or tacos or algebra books or geometry books. This one's pretty short here. The sum of two numbers is 38. And the difference is 10. Find the numbers. Okay, same problem, just a little bit different wording, because we're not talking burgers and tacos and books and all this stuff. The sum means you add the two things together, right? So this is basically your total. So your total is 38. It says the difference between the two numbers. That means one of them's got some more than the other one, right? So this is the difference. So take out the 10. And that's 28. So they equally share 28 of these things. So 2 going to 28 14 times. There's one amount. Or in this case, it wasn't an amount, this was just a number. And if the total added up to be 38 and one of them is 14, well, we're going to do 38 minus 14 to get the other number. There's 24, and there's your other number. So as long as you're just adding and subtracting the two numbers, which is basically what you're doing on those, every single time it's the same thing. They're going to give you a total where you've added the two pieces together, take that total, take out the difference or the extras, and once you take out the extras, now they've got an equal amount, divide that amount in 2, and you've got one of the amounts, and then just subtract that number from the original total, and you got the two numbers you're looking for.